Okay, I realized that last video didn't show the oscillations very clearly, so I've got set it up again, and this time you should be able to see the oscillations much more clearly. I'm going to omit the long explanation. Please see the last video for the explanation of the circuit and the hookup. So what we've got here is I'm just showing the baselines. This is channel A, which I have now. We will be monitoring the function generator input to the circuit on channel A, and then channel B is monitoring, oops, turn that off there, channel B is monitoring the output of the circuit. In this case we're looking at the voltage across the little 3-volt battery pack. Now right now I've got the battery disconnected from the circuit just by breaking the circuit, pulling one of the batteries out of the battery holder. Okay, so that's on channel B. So if I turn channel B on, what you're seeing there is a little bit of fluctuation caused by the 60 Hertz AC line, and I can prove that to you by selecting line on the trigger. So now we'll be triggering off the 60 Hertz AC signal, and you can see how that stabilized out there. So, but we want to trigger actually on the internal trigger of the oscilloscope, so we'll put up with that little 60 cycle variation right now. Okay, so now what I'm going to do is that channel, I guess, can you see the gradical illumination there? Let me turn up the gradical a little bit. No, that's not the gradical. Where's my gradical illuminator? On here, there we go. Turn up the gradical a little bit so that you can see the lines on it. So right now on that channel we are at 1 volt per division, and it's a attenuated probe, so 1/10 of a volt per division, and what we'll be reading is 1 volt per division because of the probe attenuation. So when I put the battery in there, you can see that the line goes up to read the battery voltage. So it was here 1, 2, 3 volts, sure enough. Okay, and so I'm going to take that out, and now we'll turn on the scope channel for the oscilloscope. And so there's the plus or minus 10, that's plus or minus 5 volts. Let me turn it up a little bit here. Let's go to 10 volts peak to peak, or 10 volts per division, and then turn up the output of the function generator until we have a 20 volt peak to peak output. So there's the neutral line or zero line, plus 10, minus 10. Okay, now that's with the function generator not hooked up. So when I hook the function generator up by doing this, boom, you see a substantial drawdown in the peak-to-peak voltage of the function generator. That's what that is right there. Let me move it a little bit so you can see that trace, and then you can see this massive oscillation. Now that's with the battery out, right? Okay, that's with the battery out. So when I put the battery in the circuit, okay, there you go. So up there now is the 3 volts of the battery with this superimposed oscillation that's being caused by the drive from the function generator. So now if I vary the offset of the function generator, watch what happens to that top trace as I go from all the way to the negative extreme and then start going towards the positive extreme. Okay, now back to the negative extreme. Okay, you can see that that top oscillation has a really complex kind of waveform, and it follows the output of the function generator exactly. So Let's go back to having the offset at 0. So now we're going plus or minus about 8 volts there. And there's the output oscillation. And now what I'm going to do is just reduce the power of the function generator. So I'm turning down the function generator, and the oscilloscope loses its trigger, but I think you can see, let's see if I can get the trigger back. It's not going to trigger, but I think you can see that the oscillations go away, and all you have on there now is the 3 volts of the battery voltage. So I turn the power of the function generator back up, and you can see those oscillations coming back in. And let me reestablish the trigger on the oscilloscope here. Somehow, there we go. Okay. And then now what I'm going to do is vary the offset again of the function generator. And you can see how that oscillation up there changes. Okay, now this is all with the battery in, right, in place. So when I go down here and I'm going to pop the battery out, watch what happens. Oh, wait a minute. Whoops, where are we? Boink. So I pop the battery out, and look, you get even greater oscillations. See there? Battery's out. You get these massive monster oscillations. And if I reduce, again, if I reduce the function generator drive, you see that those oscillations go away back down to nothing as the input from the function generator is reduced. So that's all coming from the function generator. Ha ha ha, surprise, surprise. Okay. And now the LEDs. Okay, with the battery out, I can vary the, once again what I'll do is I'll be varying the offset like this. And you can see there's no response from the LEDs when I do that. But if I put the battery in the circuit like that, and we're back to that pattern, and now if I vary the offset, you can see that the LEDs light either both or just the one. I'll turn off this light so you can see. Alright. So that's one LED or both LEDs. Now these LEDs are not hooked up back to back. I want to emphasize that. One of them is hooked up in the forward bias direction up here, parallel to the inductor, and the other one is hooked just across the secondary of the inductor, so it's definitely responding to AC. That one is. Okay, thanks for watching. Thanks for watching the massive oscillations of the function generator driven Ainslie circuit.